This concept illustrates the SnowPanel Restoration Climate Platform, a large-scale engineering proposal designed to investigate restoration of the Earth's polar cryosphere. The platform measures approximately 2.5 kilometers by 2.5 kilometers and supports around 2,465 IJmuiden-scale pumping units. Each pump delivers approximately 50 cubic meters of seawater every second, producing a combined flow of more than 123,000 cubic meters per second. Seawater is conveyed through dedicated intake columns to the deck, where it is atomized through nozzles approximately 100 meters above sea level to maximize atmospheric residence time under cold polar conditions. Operating continuously, the pumping system would require approximately 111 gigawatts of electrical power. One conceptual renewable configuration would utilize approximately 16,000 to 17,000 offshore 15-megawatt wind turbines, assuming a typical offshore capacity factor, although alternative power sources such as nuclear generation could also be evaluated. There is currently no scientifically validated single ice volume or ice area that guarantees restoration of global temperatures toward the Paris Agreement's 1.5-degree objective. Climate response depends on far more than ice volume alone, including geographic location, seasonal persistence, surface reflectivity, atmospheric and ocean interactions, and the Earth's overall energy balance. As one illustrative reduced-order modeling scenario, maintaining approximately 35 million square kilometers of additional bright polar ice during the sunlit season has been proposed as a restoration target for investigation. At an average thickness of 1 meter, this represents approximately 35,000 cubic kilometers, or around 31,500 gigatons of ice. Assuming a conceptual 90% freeze-back efficiency, approximately 2,500 pumps operating continuously for 10 years would process the required water volume. That seawater initially contains approximately 3,160 gigatons of dissolved inorganic carbon expressed as CO2 equivalent. If all of that carbon were permanently retained, its theoretical value could range from approximately $158 trillion to $632 trillion, depending on carbon price. Under a hypothetical 42.5% retention scenario, approximately 1,340 gigatons of CO2 could theoretically be retained, representing a value of approximately $67 trillion to $268 trillion. These figures remain conceptual engineering and economic scenarios. The actual climate response, carbon retention, permanence, additionality, brine rejection, environmental impacts, and any creditable carbon removal would all require comprehensive coupled atmosphere-ocean-sea ice modeling, experimental validation, and independent scientific verification before any performance claims could be confirmed. SnowPanel represents an engineering concept that seeks to investigate whether restoration-scale cryosphere engineering can complement emissions reduction by actively restoring the Earth's reflective polar surfaces. SnowPanel science, technology you can build today.